Yeah, so this is lecture 16. We're still going to be looking at exponential and logarithmic functions. But in this this time around now, we're going to be looking at the change of the bases. Then after that, we'll also look at the exponential growth and decay. So under the change of bases, we're going to discuss this. This is the most important thing that you are supposed to know. If you've been given log b, base a, this can also be written as log b, and then base, any base you want. So if this was, for instance, was log, let me just write it like this. This is a short form of log. Log, if this was log 5 base base 2, if this was log 5 base 2, if I'm to convert this to base 8, I'll just say log 5 over log 2, and then I'll raise all the logs to the base 8. There's a hand this side. All right, so I'm recording the session. I'm going to send it to the group. So don't worry about the network. Don't worry about the network. All right. So this is what I'm just basically explaining here. Say if you've been given log b base a, the simplest way you can convert it to any log that you want is by just doing what you write log b, and then you divide it by log a, and then you put them to the base that you want. Yeah, if you want, you can put them to base 10. If you want, you can put them to base 8, base 5, whichever base whichever base that you think of. Yeah. So for instance, this question that has been given here, we have this question to say, convert log 8 base 5 to base 2. So how can you convert log 8 base 5 to base 2? You simply say this is log 8 base 5. I want to convert this to base 2. So what I'll do is I'll just write log 8 over log 5. And then I'll now put the bases. I've been told to convert it to base 2. So meaning I'm just going to put base 2, base 2. This is how simple it is to convert the logs. You don't need anything. You don't need to put anything here. There's nothing that you need to know apart from this. This is how you convert the bases. All right, let us look at some other example. Yeah, we have examples here, which is saying find the value of x for which x is equal to log 64 base 2, and then we have log 25 base x is equal to 2, and then lastly we have log x base 3 is equal to 4. And then the question is saying find the value of x. Okay, so what you do here they are just testing us whether we know how to convert the logarithms to exponential. So let us try to convert this to exponential, or in other words, or the other way you can work out this. Actually, it has two ways by which you can work it out. Yeah. So if you want, you can just say this same x is equal to, so we say log. So this 64, yeah, so this 64 can also be written as 2 raised to power, I think should be 2 raised to power 6. Should be 2 raised to power 6. So this 64 can also be written as 2 to the power 6. And then we have the base 2 here. Okay. So when you say 2 to the power 6, 2 to the power 6 will give you 64. So I'll solve this question using the two methods, and then you choose which one is simpler for you. So you say this is equal to, so this 6 can drop down there. So you say this 6 drops down, then you have your log 2 base 2. So we know to say, according to the rules of logarithms, we know to say log a base a is equal to 1. So meaning while there is log 2 base 2, this part is just equal to 1. So I'll just write sorry, 6, and then while there is log 2 base 2, I'll put 1 there. So meaning the value of x here is nothing but 6. Yes. So the other method that you can use to solve this question is you just convert this. Let me just do this. You just convert this to exponential form. So how do you do that? This x is always the, what's this? Yeah, so this x is always the power, and then this 2 is the base. So we're going to have 2 to the power x. I'm converting to exponential. 2 is the base, and then x is the power, and then this is equal to 64. So we can say 2 to the power x is equal to, this 64 can be written as 2 to the power 6. So since the bases are the same, since the bases are equal, it means that the powers are also equal. Hence, giving us x being equal to 6. So I don't know which method is easier for you. You can choose between the two. So same applies to these remaining questions. You also do the same procedure. So you have log 25 base x being equal to 2. So even this one, if you want, we can just say, I think this one, the easiest way we can solve this one, we can maybe just convert it to, what's this, to exponential. So we're going to have x raised to power 2, and then we have this is equal to 25. So okay, yeah, so this is equal to 25. So this is the simplest way you can solve this question. And then how can we find 25, or by what means can we find 25? By raising it to power 2. So we're trying to make the powers the same. So this is going to be 5 raised to power 2. You get 25. So since the powers are the same, it also implies that the bases are the same. So meaning our value of x there is nothing but 5. Okay. So, okay, there are many ways by which you can solve this question. The other way, again, that you can solve this question is saying, okay, all right. So, okay, let me just finish up. Let me just finish this one. I want to show you how this x is equal to 5 came about. So if you introduce the the special logarithms, or you introduce logs on both sides, you're going to have x raised to power 2 being equal to ln 5 raised to power 2. So these two can drop down there. So you're going to have 2 ln x being equal to 2 ln 5. Okay. So these two and that two can cancel. And same applies to, okay, these two and that two can cancel. So meaning we're just going to remain with ln x being equal to ln 5. So from here, now the other thing that we can do here, or some people, they say if you want, you can just cancel this lien. You cancel this lien and that lien, though it's not necessarily canceling, but it also is. But it's not called canceling. There's a way in which it comes to x minus 5. Yeah, there's a way in which it will come to x minus 5 without canceling, just solving it, going down, just reducing it bit by bit. Yeah, so in other ways, you can reduce this, you can reduce it up to the point x minus, I mean x is equal to 5, sorry. Yeah, so there are a lot of ways in which you can solve this question. There are a lot of ways. So let's quickly go on to the last question there. So the last question is saying log x base 3 is equal to 4. Log x base 3 is equal to 4. So here, if we want, we can convert that to exponential. So when you convert that, it's going to be uh, 3 raised to power 4 is equal to x. This one is always the indice, this 4. And then 3 will always be the base. And then that x will always be that side. Yes. So 3 raised to power 4, 3 to the power 4, you discover that your answer is nothing but 81. So x is equal to 81. All right. X is equal to 81. Okay. So we proceed. So now let us look at this question here. This question, in most cases, mostly it gives a lot of people problems, but I guess after today, you will not face any challenges on this question. So you can, it's saying solve the equation. So when you've been told to solve something, it means that there is always a solution. You have to find the solution to that problem. Okay. So this 4x raised to power, I mean this 4 raised to power x minus 3, and then in brackets 2 to the power x minus 4 is equal to 0. There's a way in which we can convert it and make it either a polynomial or a quadratic equation. How can we do that? First, I'm going to start first by breaking down this 4 to the power x. So this can be written as 2 to the power 2. That 4 can be written as 2 to the power 2, and then this x outside, and then minus 3, 2 raised to power x, then minus 4 is equal to 0. So here we can switch this, x comes inside, the 2 goes outside. So we're going to have 2x. The reason why I'm trying to make x, or the reason why I'm exchanging the x with the 2 there is because I want this this 2x to also appear in the first place there. So we're going to have 2x and then minus 4 being equal to 0. So we say let 2 raised to power x be equal to p or y. I don't know which letter you like using, but I like using p. Let 2 to the power x be equal to p. So meaning wherever there is 2 to the power x, we can replace with p. So we're going to have p. We're going to have p squared minus 3. Where there's 2x, we put p, and then minus 4 like that is equal to 0. And then So what we're going to have here now is, or what we're remaining with to do here is to solve this quadratic equation that we have found. So you first find the factors and the product. So the product here is just, so the product is -4, and then the sum there is equal to -3. The sum is -3, and then we have the factors here, any numbers that we can multiply and get -4. When we add, we get -3. So we have negative 4 itself and +1. So when we multiply the two, we get -4. When we add the two, we get -3. So we proceed solving it from this side. So we're going to have p squared. We put in the factors. We're going to have put p squared and then plus p, then minus plus p minus 4p, and then minus 4 is equal to 0. So here we factor out the p. We factorize. We're using factorization method. So this is going to be p and then plus 1. When we factor out the p from p squared plus p, we get that. And then we write a -4 here. We factorize the -4 there. We're going to remain with p plus 1. So whenever you're solving a quadratic equation, if you discover to say what is in the brackets there is different from the other, just know to say you have made a mistake somewhere. Just go back and solve it properly. So this is our factor here. And then we also have this p minus 4, like that, being equal to 0. Okay, so we can now equate these to 0. So we have p plus 1 being equal to 0, and p minus 4 being equal to 0. So p is equal to -1, and this other p is equal to 4. P is equal to 4. So here what we have found is the value of p and not the value of x, because when we've been asked in this equation to solve, we are trying to find the value of x and not p. So how do we now find the value of x? You say recall that, recall that, so we say recall that p is equal to 2 to the power x. So meaning where there's p in our solution there, we put 2 to the power x. So where there's p, we put 2 to the power x. So in the first solution, p is equal to -1. We say p 2 to the power x is equal to -1. So to find the value of x there, we introduce the natural log ln on both sides. So we're going to have ln 2 to the power x being equal to ln -1. So the ln of a negative number does not exist. As a result, here you just write no solution. So here, no solution. We move on to the next part. We get this one. Where there's p, we put 2 to the power x. So we say 2 to the power x is equal to p. Oh, sorry, is equal to 4. So here we can find the value of x. You can either introduce ln on both sides, or if not that, you can just say 2 to the power x is equal to you change this to the base 2, it's going to be 2 to the power 2. Since the bases are the same, meaning the powers are also what? The same. Yeah, so the powers are also the same. So meaning the value of x there is equal to 2. So this is the value of x that the question has been asking us to find. So this is how simple such questions are. You don't need to stress. They are very simple and straightforward. Okay. So we proceed. Let us see what's next. Let's now look at exponential growth and exponential decay. This is also something that has been challenging a lot of people. Though today I've just prepared notes about this, and then tomorrow we're going to do a lot of solving. We're going to do a lot of questions on exponential decay, and then in lecture 17 we're going to do a lot of questions on exponential decay and even other questions pertaining logarithms. In other words, we're going to be concluding logarithms tomorrow. So in many applications, a quantity changes at the rate proportional to the amount present. In these applications, the amount present at time t is given by a special function called an exponential growth function or an exponential decay function. If the quantity n increases or decreases at a rate proportional to the amount present at the time t, then the quantity can be modeled by this equation. So this is a very important equation. You just need to know it, master it. If you can't know it, just make sure that you remember it during the exam. It's very important. If you can't know it, at least you master it. At one point, at least it's going to mature. Yeah, from mastering to something that you know. Yeah, so this n you are seeing here, it's the what? It's the quantity at the given time, at the present time t, and then this one, this n you are seeing here is the initial quantity. Then this one is the constant. It can either be a decay or a growth constant, a growth, yeah, exponential constant. And then this one is the time at the present or time at a particular or a given instance. So let us see this. Okay, this is what I'm just explaining here. Where n is the value n when t is equal to 0. Yeah, so when t is equal to 0, it's also called the initial. It's the initial value of n. And k is the constant called the growth rate constant. So if k is positive, n increases as t increases. And the equation will look like this. And it is called the exponential growth function. So when k is positive, it's exponential growth. And when k is negative, it's exponential decay function. All right, thank you for attending today's lecture. So please make sure that you don't miss tomorrow's lecture, because tomorrow we're going to be doing a lot of questions. We're going to solve a lot of questions about logarithms. Yeah, more especially those that tutorial sheet like questions. I'm going to bring a lot of questions about logarithms. So don't miss tomorrow's lecture. You need to know how to solve, how to tackle questions when you see a question or when you meet a question under exponential decay or exponential, what's this? Exponential growth. It should be very simple. So I'm going to give you, oh, somebody's saying, can we do it at a different time? All right, I've recorded it and I'll send it to the group. Yeah, I think the network I'm using here, probably, I think it's here for 2 people to do it, to complain. It means it's not you guys. I'm the one who is having the problem with network. I think it's just where I am. So I'm not using Zamtel. I normally use Zamtel. Yeah. I normally use Zamtel when doing these sessions. Today I'm using Airtel. I think that's the reason why you are all complaining about network. But please don't miss tomorrow's lecture. I'm going to send this lecture. I'm going to send the recorded one. Yeah. So don't worry about the network. The recorded one will not have will not affect you network wise. Yeah. So please don't miss tomorrow's lecture. We're going to be solving a lot of questions on logs. All right, shalom, shalom.